Alright, let me get you started, even if we don't do the whole thing. I'll just get you started on this. So we've got a curve y equals, if I divide by 4, just check for me, I wish you were with me. I got x squared on 4 there. So x, if I factorize by x, I get that, right? So my my x-intercepts being at 0 and when x equals 4, that works, right? So when x equals 4, so I've got a negative parabola, whoops, where that's 4 and that's 1. And we're talking about a line, diagonal line that goes through 0, a straight line that bisects this area that's enclosed. So if you think about this, so it must go something like this. So this this area between the two curves here, say A1, let's say this is A2. So A1 and A2 have to be equal to each other. Now A1 is the parabola minus the straight line, and A2 you can see is a triangle, and then from then on it's the area under the parabola. So we really need to know what this x value is here. How do we find that? Well, let's find their point of intersection. So if we have a look here for their point of intersection, y equals kx. So I might sub that into here, y equals kx. And then I've got 4x minus x squared. If I put everything on this side, I've got x squared minus 4x plus 4kx has to equal 0. Now that's x squared minus, they've both got 4x in them, haven't they? So this is 1 minus k, if I've got that correct. Alright, so let me just factorize by that x, and you can see that's going to equal 0 when x equals 0, or x equals 4 lots of 1 minus k's. Alright, well that makes sense because here they do intercept at that point and they also intercept at this point. So this x value here is 4 lots of 1 minus k's. Alright, so now if I wanted to find A2 using the triangle plus the other area, I would need to know the height there. So why don't I just sub that in and find the height while I'm there. So sub that into y, so y is the height, where x is 4, 1 minus k, and you can see it's 4k, 1 minus k. So this is has a height of, I'll say y equals 4k, 1 minus k. Alright, so I think we've got the information that we need in order to find the value of k, which does bisect that area. So let's look at A1. To start with A1, well, that's the integral going from 0 to 4 1 minus k's of the parabola minus, so purple minus blue, so parabola, which is x minus x squared on 4 minus the area under the kx. Alright, so let's have a look at that one first. So we've got x squared on 2, oops, minus x cubed, add 1, divide by 3, so you get 12 there, and kx squared on 2. Alright, so it's nice because if we put the 0 in, we get 0 because everything's got an x in it, so that's fine. We could factorize before we sub in. Should we not? Let's say we did a quick factorization. So we've got x squared on 2. They all have x squared on 2 in them. 1 minus, I don't know if I'm making this harder, x on 6 minus k, 0, 4, 1 minus k. Alright, so here we've got 4 4s are 16 and 1 minus k squared on 2. And then in brackets 1 minus 4 1 minus k's on 6 minus k. Alright, so we've got 8 1 minus k squareds, and here we've got something interesting. 1 minus k, I'm going to put the 1 minus k there, and if I want 6 I could actually, let's just do that, so 6 minus, let's put everything on 6 in here, everything on 6, so this would be 6 on 6 minus, and this is already on 6, so 4 plus 4k's minus 6k's, all on 6. Just trying it a different way because I got a wrong answer before. Alright, so we've got 6 minus 4 is 2. So we're going to end up just that bit. Let me have a look. That's 2 minus 2k's on 6. So 1 minus k on 3 is what we get. So 1 minus k on 3. So this will really be 8 on 3 and 1 minus k cubed. Alright, I got that last time, but anyway. Alright, so this is A1. So I'm just going to point to A1 and write 8 on 3, 1 minus k, all cubed. Let's see if we are okay there. So that's A1. So what about A2? A2, so will be that triangle, which is half the base being 4 1 minus k, times the height being 4k 1 minus k. And then we're going to put the integral on as well, but I don't have room, so let me just go over here a bit. So half times 4 is 2, 2 4s are 8, so this is going to be 8k 1 minus k squared. Alright, so that's what we're looking at the moment, plus the integral. Now the integral, I want to go from that 4 1 minus k all the way to 4 of just the parabola, because it's just this bit here. So the parabola being x minus x squared on 4 dx. Alright, so let's just have a look at that bit. So we're going to have x squared on 2 minus x cubed on 12. And that is between 4, 1 minus k, and 4. Alright, so if I sub in, well, let's do the same thing just because. X squared on 2, if I factorise by that, I'm going to get an x on 6 here. Alright, so if I sub 4 in first, I'm going to get 4 squared on 2, 1 minus 2/3, so 4/6 minus, then I'm going to sub in the 4 and the 1 minus k, so 4 squared 1 minus k squared on 2, 1 minus 4 1 minus k on 6. Oof. Alright, so 1 minus 2/3, just this bit here, is 1/3. So we're going to get 4 squared on 6 here. Alright, over here we are going to get 4 squared 1 minus k squared. I'm going to keep this as 2. Whoops, that's a minus. So here on 6, I'm getting 6 minus 4 minus, so plus 4k's, all on 6. Alright, that's 2 plus 4k on 6, is it? Alright, so that's 1 plus 2k on 6. Okay, so this 2 will cancel with this 2, and I'll get 4 squared on 6 minus 4 squared 1 minus k squared, sorry it's hard to follow me, on 6, and we've got 1 plus 2k, 1 plus 2k. Alright, you get the general gist. You at least get what we're trying to do, even if I've made a mistake somewhere, which would not surprise me at this stage. It's I've too far gone really, and no checks in between. So I think that was just for this integral part, wasn't it? Nearly lost that. So I've got 8k's 1 minus k squared plus, whew, okay, here I might factorise by 4 squared on 6. And so we've got 1 minus 1 minus k squared 1 plus 2k. Who knows if I'm right? Alright, but I will keep going nevertheless. You're welcome to stop if you think I've gone wrong somewhere. Alright, so if I look on here, I'm really going to have to factorise, I think, which is a bummer. Whew, 1 minus, alright, so this will be 1 minus 2k plus k squared, 1 plus 2k. So it's going to be 1 minus, alright, here we go, 1 minus 2k plus k squared. When I times them all by 1, and when I times them all by 2k, 2k minus 4k squared plus 2k cubed. Oops. So at least the 1 minus 1 cancels, but then I'm left with 2k, oops. So the minus 2k and the 2k cancel. So in this bracket, I better do this bracket first. I get 1k minus 3k squared plus 2k cubed. Alright, and then of course I've got 1 minus that. So actually that's going to end up being 3k squared minus 2k cubed, that part. So k squared 3 minus 2k. Wow, that's looking weird, but anyway, say it was that. Again, running out of room, so if I do it in a different colour pen maybe, 8k 1 minus k squared, and this would be 4 squared on 6, so I'm going to do 4 on 6, so this will be 2/3. So we've got 8/3 there. 8/3 k squared, I'm just adding this bit down here, 3 minus 2k. Alright, and what we know, even if this is not correct, what we know is that area 1 has to equal area 2 for if that line bisects. Right, so let's make area 1 equal area 2. Where's area 1 gone? It's over there. So area 1 was 8 on 3, 1 minus k cubed, and area 2 is 8k 1 minus k squared, I wrote that wrong, plus 8 on 3 k squared 3 minus 2k. Alright, so we need to equate these. Interesting. So I guess I could expand everything, which is such a bummer, but hang on, everything's got 8 in it, so let me get rid of the 8 first, and then I'll have to expand, although it might times everything by 3 as well. So get rid of that, put a 3 on that one, and get rid of that. Alright, so 1 minus, I'm just going to write it up here. Run out, don't blame you if you've lost interest by now. So we've got 1 minus k all cubed equaling 3k 1 minus k all squared plus k squared 3 minus 2k. Alright, so let's go from there. I keep rubbing stuff out, so I'm sure I've made a mistake somewhere. 1, 3, 1, 3, 3, 1, 1, 3, 3, 1, binomial expansion. This will be 3k lots of 1 minus 2k plus k squared. This will be 3k squareds minus 2k cubes. Alright, so this bit will be 3k minus 6k squared plus 3k cubed. 3k squared minus 2k cubed. Alright, so just on the right hand side, I guess. Let's go. We've got 3k. How many squareds? Minus 6 plus 3, so minus 3k squareds. Cubes, we've got just 1k cube. On the other side, actually, we can then cancel the k cubed. And so if I put everything on this right hand side, I've got a 1. And I've got minus 3k, and I'm going to minus another 3k from the other side. I've got 3k squared. I'm going to add 3k squared, so that's 6k squared. Oh my goodness. Alright, so let's have a look. So if I was solving this 6k squared minus 6k plus 1 equals 0. So let's use quadratic formula. Negative b plus minus square root b squared minus 4ac, so 24 on 12. So this is going to be 1 plus or minus 30, so 12. That's right, isn't it? 12 square root 12. 12 is 4 threes, so it's going to be 2 root 3 on 12, so that's 1 6. I did put on 6 already. Oh no, I've got it on 2. Whoops. What have I done? See, trying to go too fast is the problem. I'll do bit by bit. So this is a half plus minus, and here I'm going to get 2, so root 3 on 6 is what I'm going to get. Now, whether that is correct or not, hopefully you get, I could also put it in and check the areas, but hopefully you get the gist of the way to go about it. So we're trying to find where this area A1 has to equal the area A2, and A2 is made up of kind of 2 parts there, so be careful what your top and bottom curve are.